Okay. Good morning, ladies and gentlemen. Come on, louder. Good morning. Woo! They're alive. Thanks God. So, I'm really happy to introduce our first speaker today. He came to us from wonderful country. Who knows which country? Yes, definitely. It's really wonderful country and really great people living there, by the way. Our first speaker has largest Node.js best practices Git repository. Yep, he is Node.js consultant. Remember yesterday last speech about what to do after senior? He knows too what to do. So, welcome, Yoni Goldberg.
Thank you very much. Thank you. Okay. Good morning, Kharkiv. At least those from Kharkiv who didn't party until 2 a.m. last night. I'm so excited to be here. Really wonderful conference, so unique and special. Thanks for having me here. A few words about myself before we start. My name is Yoni Goldberg. I'm an independent Node.js consultant. I work with big enterprises like Intel and Cisco and garage startups about polishing their Node.js applications. At least half of my projects are about testing. I'm really passionate and I really enjoy learning about testing. And I summarize all the insights that I learn at my repositories, Node.js best practices and JavaScript testing best practices. It's kind of my child project. I really love it. It's one of Node's top 10 most shared projects. So I'll be glad if you pay a visit. What are we going to speak about today? What's new in JavaScript testing? And just to get to know you better, just a question, who here knows what's the difference between unit test and integration test? Oh, that's good. You're a great audience. Who knows what is the testing pyramid? Sounds great. Cool. Just one short disclaimer. This talk is not about the basics of testing, rather about the newer parts. So if you're new to testing, make sure to also go over the basics. Cool. And I got to tell you, big things, really big things are happening on the testing domain. For this talk, I conducted a survey. I shared it with 300. I shared it over the web, and 300 developers around the globe filled it. And one of the questions I asked was, did you test this year? Did you create more tests this year? And I focused only on experienced developers, those that exist in the industry for years. And almost 70% of them were saying, yes, this year I tested even more. Other examples, this is taking from the survey State of JS. And they asked, are you happy with your developer tools? So interesting stuff, as you can see, the green one represents testing. And as of 2016 and 17, there was no change. People were quite not happy with the testing tool. And suddenly, in 2017, there is a big jump, being in client satisfaction, which is very interesting. Suddenly, such a change, such a movement. What is the reason for this? Let's find out. Okay, so we're going to speak soon about understanding the trending and challenges in JavaScript testing. And I gotta tell you, there are many new challenges for you as a developers. And understanding this now can make a big difference in how you plan your new project. Yeah, that's a good idea. And then on the next part, we will see how you can mitigate those challenges. So we're going to start with some background trends, and then we're going to drill into examples and code and tools. Some context first. Now, speed is kind of everything for the development world. It's the most important word that your CTO is speaking about and hearing in all the conferences, all the research companies emphasizing speed, speed, speed. In my survey, I asked developers, what is now the role of QA in your organization? And surprisingly, 42% mentioned that no more QA. And not because of budget reasons, only because QA slowed them down. It is a block before production. We don't need this block. We want to move faster to production. Other important trend is what's called the shift left approach, which suggests that the later you discover a bug, it is much pricier to fix it. If you look at the traditional model here on the gray, this is how people used to work a few years ago. We were first coding and testing a bit, but the heavier part of testing, end-to-end performance integration, were done before production. And then researchers found that if you discover a bug there, it's 100% pricier to fix it. Think about performance issues that you discover too late, then you have to shift back and change your data model. Or if you're on the front end, then maybe you chose the wrong data grid libraries that is not working on old iPads. You have to perform some very major architectural changes. So the shift left model suggests that you should include most of your testing, including the heavier one, as early as possible, maybe on every build, every night. And this makes sense, but is it indeed realistic to find the serious bugs in development over developer machine in development time? So here comes the shift right trend, which is quite new and popular. And what it dictates is that, hey, you left, shift left people, you know nothing. The real bugs are discovered on the right side, on the production-like. I know this is a bit too small for you, the people from the behind. Here what we have is security, monitoring, testing in production. So basically what the shift right person suggests is that you will discover most of your bugs on the right side. One example from my project, we were developing a version. Everything seemed to work perfectly. We put it in production, and then we've seen a lot of latency and errors. And while we investigated it, we found out that only on iPads, old version of iPads that apparently many of our customers are using, we're using the AWS SDK, which works with S3 in the cloud. And there is a bug in this SDK only on old version of iPad, which causes it to freeze. And it affects many of our transactions. We had no chance to discover that in development area, right? This kind of bugs you can discover only in production. So there is now a big trend, a really big buzzword, which is called testing in production. You'll hear it for sure in the next few years in other conferences. And this is what the shift right approach is about. Try to shift many of your testing to production. And it doesn't mean you really test on production. It means that there are a lot of technique that can make your test more realistic. For example, you may craft a staging environment that gets all your production data and replay all your production data. We're going to see a demo soon. And then you can test over a realistic environment. One other important trend is that, I'm not sure if you're aware, if you want or not, you have new responsibilities. You are now also at least partially ops, not only dev. So it's your responsibility now at least to be involved in monitoring, in security, in a lot of things that are on the right side of the map. So shift left, shift right, it's a bit confusing. Where should I shift exactly? Luckily, the testing industry has a new buzzword that makes more sense, I think, which is called continuous testing. Now we can think about our entire development pipeline holistically and understand that we have to test everywhere. Every phase deserves its test. And we can now plan in advance our entire pipeline. And we can also mix and match. For example, I had now a case with the customer where on the coding phase, we try to test something, but it was very hard and expensive. we thought that it would take 2 weeks to test it. So instead, we decided to create a metric, monitor metric, to discover issue there, and we just monitored for it in production. When something wrong happened, we immediately fix it. So you can mix and match across the pipeline to optimize your testing strategy. So what exactly should you test in each phase? Well, apparently there are a very long list of testing that most of us are not aware of, and there is a test type for each step in the pipeline. Don't try to read this list, it's a long list. The idea here is that just bear in mind that if you make yourself familiar with more testing type, you can match more solutions to more problems. And I will exemplify some of this testing very soon. So this was kind of an overall context, and now let's see how it affects your daily life as a developer. So I think that based on all of this, our main concern and challenge as developers is now capacity. Because we have to test more things, and we are asked to move fast, but frankly, no one will assign you more capacity for those more testing. So if you look at the orange circle, is your capacity. This is, if you are lucky, what you have right now. You are able to test, to write tests. Most of my customers, by the way, don't have even this, and I also spoke with a lot of people here who are not even given the time to test at all. So if this is your capacity, how do you cover all the circles? If you will try to move it right, you have to sacrifice something. So I think this is your main challenge. How do you address it? Let's discuss it now in chapter 2 and chapter 3. So in training, we have a lot of challenges. Tooling is one of the ways that can buy us more time and help us be more efficient. And great things are happening on JavaScript testing tooling. Just to give you an example, to emphasize this, these are the metrics of non-testing tooling, like Loggers, ORM, and you can see no big dramas. The lines are pretty linear, right? But when we look at testing tools, this looks like a drama, like a revolution. Look at the lines. So many things are happening. For example, on the browser automation, Selenium is going to drop from number 1 to number 3 in 2 years only. Also on the test runner era, Jest and Java are gaining much of momentum. But maybe it's just another JavaScript trend. Now there was so many tools that gained a lot of popularity just for no good reason. So yeah, maybe. But my take on it is no. I think that Jest and Java are really changing the game. And it doesn't matter what tool you use. Just take care to understand their unique features and consider having them in your next project. So first, at least Jest are coming as one bundle with all-in-one. Everything you need for testing, bundled there together. No need to set up for a long, at least if you're a young developer, spend a day or two on setting up your testing environment. You get it almost instantly, or at least in a few hours. Also, they pack built-in speed intelligence. They run tests in multiple processes, and they try to apply a lot of intelligence while they're running your test. For example, they calculate your testing history, and with time, they will try to run the slowest test first. This way, they will reach optimize overall testing runtime. But the most important factor is a delightful experience. They become a truly convenient friend that can handhold you during development. And this is better explained with a short demo. To shorten it, I prefer to show it from a video. So what you see on the left side is just typical code components that I create. And on the right side, you see Jest in watch mode, running test while I code. Okay, sorry. Here I'm adding some code, and see that on the left side I'm adding code, but on the right side nothing is happening. and I'm adding some more code, and on the right side, nothing is happening. And that's it, basically. So you might wonder, what? This is the worst demo I've ever seen. What this man on stage wants. And I think it's great, because it gives you a quiet peace of mind while you're coding. It does things. It runs your test in the background. It even tries to guess what test should be run based on the code that changes. But it tries not to bother you. Other test runners, what we'll do, will show you tons of console log lines and test reports, and at some point you'll say, okay, stop it, I can't have this noise. You'll just quit the test runner. And then when there is a bug, you'll discover it a few hours later. So just try to be a best coding companion and keep quiet. But when there is an error, it will surely tell you in a very intelligent no. By the way, we will arrive to Justin Bieber later. What did I want to? That's interesting. Okay. I have some videos that just disappeared. Let's try playing it from here. Okay, so whenever I will have an error, you can see on the left now that my code has an exception, just right away quits the silent mode, pops up a message for you, and, as you can see on the right side, not only telling you, hey, some testing failed, it goes to your source code, and when there is an exception, and provide you with the source code, the exception, and all the surrounding lines. So you can right away say, hey, okay, I think that I know where the exception is coming from. Now, when there is no exception and you are just returning the wrong value, as you can see here, I have an array. It should return a banana, but mistakenly, no banana in the response. This would be just error, not just, well, the received value does not match my expectation. It shows you exactly and highlight what is missing. Okay? Try to save you time and be very focused on what's wrong. Okay, so some test is not working. Now you want to drill down into the test and run it. How do you do it? So just have a very rich watch menu. It allows you to run only failing tests, test and change scene master since the last pull. One of the neatest options is you can type the test name and get an autocomplete. And then you can focus right away on the test that is interesting more. Okay. So it's meant to be a very friendly and convenient testing convenience that you want to include as part of your coding experience. Let's go back to the slide. Okay. Other important tools are what I call the free lunch quality tools. Those are, why do I call them free lunch? Because testing is something you always have to work for, right? You have new features, you have to write more tests. But there are tools that with one setup will cover you and catch all sorts of issues. Like, I wish I could cover each one of them, but time-wise I will just very briefly go over them. Visual regression will help you semi-automatically catch if for one of your front-end devices, browsers, Opera, Chrome, whatever, Safari, there is a UI difference, it will catch it right away and notifies. And there are deployment verifiers, which works against your bundle and will try to identify load issues, packing, bundling issues, all of this automatically, one setup. And tools like Storybook that will, after you have testing, will transform them to live style guide and live documentation. And of course, static analysis and linters. And yeah, I know that you're using ESLint, but the list keeps growing. So there are a lot of new static analysis and linters going on all the time. And you can, with 5-minute setup, catch dozens of tomorrow's production issues, right? Like next, new linters can catch if you use promises and forgot to resolve. Absolutely production bug, right? Catches right away. You threw an error, but it's not a valid JavaScript error. You lose the stack trace, catch it is right away. Dependency cruiser will tell you if you're using a dependencies is not in package.json. It won't get bundled. So few minutes setup and you get guard for additional a lot of quality stuff. Yeah, so a lot of new tooling that can buy you, and I just scratched the tip of the icebergs. There are many like Cypress and others. A lot of new tooling that will buy you a lot of time, but mostly make your testing experience much more delightful, make you want to test more. And still, I would argue that with all the great new tooling, it won't be enough to gain you the time to cover the entire spectrum of testing that we've seen before. You have to have a better testing strategy and technique, and this is what chapter 3 is about. Okay. So testing, now you have to start testing your new project. What exactly do you do? If you think about having like testing everything, having 100% unit test and integration and end-to-end, you're lucky to run out of your capacity. I've merely seen this work, that testing so much could stand to the project capacity and speed. So what do? You have now the capacity for this, but you have to span much more circles. If you try to move right, you lose other areas. What exactly do you do? So this is the thing. Testing is a best guess game. And what I mean is that if you have a component, you can easily think about 200 type of testings that you can do there. But practically, you have time for maybe 10, 20, 30% of them. So how do you prioritize? Which type of test are you going for first? Let's think about it. Maybe unit tests. Maybe prioritize unit tests. Well, I think they are great for some specific scenarios, but for most projects, and I'm referring more to like production microservices, not to NPM packages, I think they are way too pricey. Testing each of your function as your main testing methodology, testing each function in your system is very tedious and time-consuming. And not only this, even if you do all this investment, they by design don't cover some very painful layers, right? Like database, DOM, API. So if unit tester looks at this image, they will ask, is something wrong here? Everything seems perfect, right? Each unit works perfectly by itself. And the web is no short of funniest meme on unit testing. As you can see, the dryer and the garbage can, each by itself works perfectly. Together, I'm not sure. This is my favorite here, because really here, everything is cool. Nothing should be wrong. It's just a socket and... yeah. Yeah. Okay, so if not unit tests is our main testing methodology, maybe let's go for integration, big integration and end-to-end testing. And I think also no, it will slow you down. Why? Because the entire reason that you are working on small component, whether it's backend microservice or front-end isolated component, is to work on small thing, right? Low complexity, we move fast. So you're working on your orange, nice component, it's very small. But then when you need to test and deploy it, it becomes this. You have to craft the entire 20 other microservices which you're not aware of, or the entire front-end page. This will surely slow you down. So what do? One of the useful techniques that I find useful is component test. And there are a combination of unit and integration. They are somewhere in the middle. So if you like unit test, but they are a bit not realistic and pricey, and integration test might be slow and fragile, component test might be what you need, because they presumably tick all the boxes. How exactly? So the basics first, on component test, we start from the user perspective. This is backend. If it's backend, we're going through the API or the message queue, and we are going through all the real layers of the application. Realistically, what the user is going through. If it's backend, probably the DOM, not necessarily on the browser, but think from the user perspective. Bless you. And then you try to focus on one thing. Anything he's doing externally, calling other microservices, calling the backend, whatever, you stop it, you fake it, we want to focus and spare I/O. And we also try to speed it up, to make it like unit test in terms of speed. No animations. If we have a database, make it in memory, very easy with MongoDB. It's almost easy with Postgre and MySQL. So this way we get something that is both very exhaustive and realistic, but fast almost as unit tests. So just to show you a code example, this is taken from the backend side. Don't try, I know it's too small, we will see it soon on larger. It's a very typical test, 5, 6 lines of code with prettier, obviously it becomes 12. And basically what we do here is we test the order microservice. Okay, we test the order microservice. Let's see now each part of the test. So the order microservice is calling the user microservice, but we don't want to involve other components. So we use knock, a library that intercept network request and will prevent that network call. Less I/O, we prevent this I/O, prevent this flakiness, and we force it to reply with this thing. So no I/O, we don't want I/O in our test or other components. And then we go and we instruct our database layer to use MongoDB in memory. There are many ways to achieve it. It's too long to cover it now, but if you have no network and no database I/O, think about it, you are almost in memory. And then, okay, we are ready. We want to execute the API. Very trivial. One point of interest is that I'm using here a super test, a library that allows me to pass in the express application, which means, look here, I don't call a fully qualified network URL. So the idea is that my test and the unit under test, the API, are on the same process. Why? It allows me to benefit from all the features of unit test. They are on the same process. I've code coverage, test doubles, mocks, intercept network request. I can simulate a lot of scenarios. And finally, expectations, very trivial, right? I don't have too many words to add on that. So yeah, I really like, and it works great for me and for my customer, component test. Also in my survey, I saw that many developers are kind of starting to implement this. And it's also really fast. Sometimes I hear from unit test people, hey, but it will be too slow for me. So I created a benchmark, and I ran 200 unit tests in memory only, just a function call, and 200 component tests. Each one of them has 2 API calls and 2 database calls. 200 we run in 4 seconds. Unit test we run in 2.6. So it's only 1 second, 0.4 difference. It's, I think, not something that has any meaning in your development cycle. Last, maybe worth mentioning that there are a lot of also challenges in component tests. You have to think how you work with database, tear it down, seeding, but we will cover it probably in the other opportunity. So yeah, this might buy you, this might leanify your testing and might gain you much more confident for a much shorter investment time. Now we are good on the left side of the map, right? We have maybe a better testing technique, but how do we test the right side? Remember the production, testing in production, all the realistic testing? So there are many techniques. And I thought, what do I want to show you today? Where do I want to focus? So I asked developers, what are the most frequent causes for production issues? And I thought, based on this, I will match the right testing technique. And I was very surprised from the result, because number one makes sense, it's logic bugs. Yeah, makes sense, there are also integration issues, but number two, on the right side, can you guess what was number two? It was unpredicted input. I could not guess what the input that will feed into my component. And it makes sense because we are in the area of loose schemas, JSON, MongoDB, even the structured database, biggest feature of the recent years is JSON columns. And we have so many dynamic sources of information. It's not only human being, it's bots, it's devices on the field. And also our code right now, with all this NPM outreach, can run in so many different situations. Think of it, you are a Lodash developer or developer in Google V8 team. You created now a method that compares strings. So how do you test it? You try it with 3 values, 5 samples, 7. But then in production, millions will stretch it in so many different permutations. How can you get this confidence? So luckily, there are multiple testing techniques to deal with rich type of inputs. I will cover some of them and show you a quick demo. The first one is fuzzing. Just curious, who here knows what's fuzz testing? Cool. I wish I could show you a demo, but I will just go very briefly over some of them and then focus on one. Fuzz testing means tools. There are a lot of tools for that will send a lot of random data. Some of them is data that is known to be malicious, and it will try to take down your application, whether it's your API or there are even some tooling for front end. So the aim here is to try to identify where your application crashes or gets into a DDoS condition. And it's very cool, but we want to test more than this, right? We want also to test for correctness, only to see that our components bring back the right values. So this is where property-based testing comes into play. It's a very powerful technique. I urge you to read about it. It basically randomizes a lot of data to your method. So if you have a method with 5 parameters, it will call it 100 or 1,000 times with different combination and permutations and tells you when it returns the right value. It's very interesting. But I want to focus today on another one because it's more testing in production-like. So the problem with property-based testing is that it's synthetic data, it's randomized data. But the most realistic one comes from production, right? So traffic shadowing, what traffic shadowing does is that it takes your production data, input, live or maybe later, and play it against your testing server, your next iteration. And then it sees if your components are ready for the richness and unpredictedness of your production data. How exactly does it work? Let's see. So we have a lot of users or devices of sometimes thousands of different data generators. And they call our production, right? Number one there. So we need a shadow tool. Some tool, there are multiple open source tools for that, which will capture this information and store it in optionally store it in some storage for later replay. And then, immediately or afterward, it will get replayed to your testing environment. So you can land your next version there few days before you're deployed to production and see whether it can handle all the production data. Then you can look in the staging environment over your metrics, error rate, CPU, and if it tends to behave like production, and normally you get much more confident. If you want to take it even one step further, you can also compare. See that every response of your staging and server matches, same HTTP status, for example. And then they seem to behave similarly. So this is one of the techniques that is part of testing in production. Usually people speak about it in an abstract way using slides. I decided to create a demo. So help me the God of demos. So let's see how exactly it looks live. Okay, let's start the production process and the staging one. Okay. Cool. So what do we have here? This is based on a real system that I'm working on with one of my customer. It is a smart car garage. What does it mean? We have tens of thousands of cars, and each one of them has a smart tracker in it. So they report with diagnostic information about themselves. The engine, the oil, the tears. It's a big JSON with a lot of diagnostic information. Now, there are many different types of trackers. So we have to handle 100 different types of schemas. Okay? So each car is sending constantly to the cloud, big JSON with some schema with diagnostic information about itself. What you see on the left side is the production, right side is staging. Now I'm developing the new version, and I'm asked to add this code. Sounds trivial, right? If the temperature goes above 100%, 120% temperature, shut off the tracker. But there are so many cars and trackers as schemas that I'm not confident enough whether it will work for all scenarios and all situations. It's very hard to test for this because we have so many different type of trackers. So what do? I have 3 days before deployment. I'm ready, more or less. I want to play the production data into the right side, into my staging, and see that they behave the same. So how do I achieve this? Basically, whenever I click here on every car, you see the number increasing here. It means that this car sends an updates, but nothing happens on the right side, right? Obviously, it's a different environment, might be different cloud. So how do I map the traffic from production to staging? I have to use a tool. In this demo, I'm going to use a tool which is called Go Replay. It's one of the open source tools for traffic shadowing. So basically, with one command, this one, I can intercept all the network traffic to production and send it to different cloud, different server, different whatever. So now, when I will click on the car here, you can see them. The number is also increasing here. Okay? The traffic is mapped. So if I click on the button Simulate here, it will just replay with many cars, and it will simulate production behavior with many updates from car. And I want to test it for a few days. If everything will be cool, we will see this kid doing that sign. If not, what will happen? Well, okay, so a small story. This takes us to Justin Bieber. I had a talk with my friend, Daniel, who is a known NPM contributor, and we thought how much impact you can create with NPM packages today, or with code. You can solve real-world problems like energy problems, anger problems. So we thought, what is our next project about? And he told me, I have an idea. Let's create a test runner that every time a test fails, plays a Justin Bieber song. And I was kind of, what? It's a dumb idea. I don't know how he convinced me to work on this project. So if our test will fail, you will hear a Justin Bieber song. I apologize for that, and crossing my fingers that everything will work. So I'm clicking Simulate here. And if things works correctly, you should see the number growing on both sides. I think they do. Yeah. Can you see everything that is being played to production is also mapped to the staging. So it can be 3 days with millions of requests. And not only this, the tools also compare. If some production route will return some HTTP status and staging a different one, the test will fail right away. And it gives me so much confidence. Okay. Just fail, Justin plays. You have to get punished if your test fails. So I think Justin Bieber is a good. It will show. It's one other tip. If you want to write better tests, this is a. So what happened here? What's happened here is that one of the 100 trackers that we have, one of the cars doesn't have a temperature attributes. And as a developer, it's really easy to fail and miss one scenario. And I couldn't predict it in development time. But thanks to real production data for days, I was able to identify this error and fix it early enough. So this is an example of testing with production data, and there are many other techniques for testing with production, can help you ship better code. Let's go back to the slides. Yeah, so key takeaway from my call today is first, as you see, I hope I was managed to demonstrate it to you how the testing world is really being disrupted. So many new tools, new approaches, new challenges. And you have many more responsibilities. Try to embrace it, understand it, prepare for this. But luckily, there are also many new tools and technique and approach that can help you mitigate and cope with these new challenges. So it was a pleasure being here today. Really, thank you a lot. And I really must have a selfie with you, so please, hands up. My mother asked for a selfie. Cool. Thank you. I'll be glad to stay in touch. You have here multiple ways to follow me. I'm here for question, discussion also afterward. Really, thank you.
Thank you, Yoni, for a great speech. Actually, honestly, you inspired me to write some tests in my project, which I'm not doing often. This is my
biggest achievement today.
Yep.
Although I'm not sure that I want to see how the test looks like.
Okay. So we have a few questions to you from our community. Do you know any cases where test doesn't need tests?
Oh, this is a really great one. Yeah, of course. I think that in overall test is something that should has a value and price. So you have to understand, every time you're writing a test, you are now paying some price, your time, your maintenance time. So you have to think, what is the likelihood of this error? You have to think about the risk. What is the likelihood of this risk happening? How much time will it take me to fix it? What is the impact of this error? If you're spending 1 hour on testing that the image as an alt text, so the user will see an alternative text over the image, I mean, the impact here is almost nothing, and fixing it takes 10 seconds. It probably doesn't worth the test. So you have to think about, I have a big risk. It worth my time to spend some 10 minutes, 1 hour on mitigating it.
Cool. Actually, you answered for a few questions. I can skip it. So what do you think about test-driven development and related testing first approaches? Should developers write tests before business logic code?
Can you repeat the second part? I heard the TDD and?
Yeah, TDD and related testing first approaches.
Yeah, TDD and its brothers.
Yeah.
I think that TDD does not equal testing. For many people, especially the TDD people, TDD is testing. So I think TDD is technique, a very interesting and powerful one that works for some people. It doesn't work for others. It doesn't work for many of my customers. We can change people, right? So I think it's another technique you should consider in your basket. Not necessarily the only one. I think this is my short take on it.
Okay, thank you. And what do you think about snapshot testing for React components?
Yeah, so as part of, I won't say only what I think about snapshot testing, I would tell you also what the community. I try to evaluate trends and thoughts for this talk. So I went over the recent 20 articles about snapshot testing. About 30% was negative. I think that there is a growing consensus that snapshot testing is dangerous. You're trying to test in one test for assert for 100 lines of code. It's risky, so you have to be careful. I think if you work with it, be sure to work on very small payloads, like 3 lines, 7 lines, 10 lines. If you are asserting on 200 lines, make sure you understand that it will likely to be very fragile.
Okay, and one more, my favorite actually. what's the theme in VS Code?
What is that?
What's the theme?
Ah,
you use?
yeah. I just really like purple. Well, VS Code has an extension that can sync all your settings in your skins to the cloud automatically. So I will just share, I don't remember, but I will share with you my GitHub, and there you can see all my VS Code settings.
Thanks a lot. So which question do you like more?
Which was my favorite question?
Yeah.
About the theme?
Okay.
No, I'm kidding. I think that TDD is a very interesting topic that...
So Igor L, who is Igor. What do you think about TDD and related testing first approaches? Who wrote this? Come on here. Not sure.